Let's take a look at section 2 of project 2. This corresponds to lesson 7 of algebra 2b. Their first question is kind of a general question about the half-life formula. I will say now that this whole section of the project, hopefully you've already read it, is all about doing half-life problems. If you skipped over, don't remember, rushed through the half-life section of today's lecture, please stop, go back and reread that section now. They give one very detailed example. It won't take you more than maybe 5 or 6 minutes to kind of refresh. Okay, it's the one about someone having a headache and taking painkillers. Please reread that section. Without that kind of context, this is going to be a lot more difficult to understand. So we have this wizard that uses potions on people, and he needs to know how long it takes for potions to wear off. So we want to explain in a few sentences how we can take this general formula and rearrange it in order to calculate the half-life of a substance. Please use as a model that painkiller or headache example from the lesson. Just like the lesson gives you a step-by-step, here's how we're manipulating and changing this formula to get it in this format that we want, use that as a template to answer this question, okay? Your answer should be a few sentences long. I would say at least 3 sentences is going to be needed to kind of convey fully your message, okay? So remember, the goal is to get your function in a format that looks like this, okay? Where QT is the amount or the concentration, QO is the initial, okay? 1/2 is the ratio or percent, and then T, in this case, I think we're talking about time, and then H is the half-life. So, again, QT equals Q sub 0 times 1/2 to the T over H. And remember that half-life, this H that we're trying to figure out, is the time taken for a property to decrease by 1/2. So in this case, that property is the concentration of the potion, how long it takes the potion to wear off. At what point is the potion 50% worn off? All right. And then look at the way that each of these are kind of corresponding to each other. So we've got this Q of T. In this case, A represents Q sub 0, or the initial amount. 1/2 is representing B. But, how are we going from T to T over H? Think about the exponent rules that they show you and that they use to rearrange functions to fit half-life models. Alright, so 3 of the potions the Plaid Wizard often works with are star sand, diamond dart, and liquid light. In the formula that represents the amount of star sand in a creature's body is given by this. What's the half-life of star sand? So S of T equals 16 times 1/7 to the T, and we need to find the half-life. Okay, so I'm not going to, as usual, I'm not going to use this exact problem. I'll model a similar one, though. Let's say I had C of T equals 19 times 1/5 to the T. And I wanted to figure out this half-life here. Okay. Remember that the format that I'm looking for ends with me having this T over H, right? I've got Q of T equals Q sub 0 times 1/2 T over H. How am I going to get from here to something that looks like that? Well, I am going to manipulate this. I'm going to make my C of T equation actually look more complicated by using my rules about exponents. So if I want to get something that looks like T over H, I can do that. Sorry, my screen keeps flipping. I can do that by dividing by H, right? But I've now just kind of tampered with my equation. It's no longer equivalent. I've changed it completely. This is not the same equation as it was. But what about if I have a multiplication by H in here? So in other words, what if I take 19 times the quantity of 1/5 to the T? What if I multiply that by H over H, right? Because isn't H over H equal to 1? So this is equivalent, right? This is equivalent. And then what I say is, all right, well, I'm just going to leave I'm going to rewrite, instead of having T times H over H, I'm going to rewrite that as T over H. I'm allowed to do that, right, because this is T over 1. I'm going to leave this as T over H times H. All right, T over H times H. And then I say, you know what, I'm going to leave that T of H on the outside, or T over H on the outside of the equation, and I'm going to move H on the inside. All right, and this is, again, explained in more detail in your lesson. But basically, I'm allowed to make all these little manipulations because of exponent rules. Okay, and again, I'm trying to keep this a little bit more brief. This is not meant to be a substitute from your lesson. This is just meant to be a project help video, right? But keep in mind, again, I'm allowed to do this. I'm multiplying by h on the inside of the parentheses. I'm dividing by my exponent by h on the outside of the parentheses, because it gives me the format that I want, and it keeps my equation equivalent to itself, okay? So again, allowed to do this through the properties of exponents. So I'm even going to rewrite this just to clean it up. So now I've got c over t equals 19 times 1/5 to the h, and this is the whole thing being raised to the h, times t over h. At this point, I can use my little calculator, that half-life calculator that was provided for you in the course. Remember that I'm looking to figure out when the inside of this, and I'm going to equate it to 1/2. So to rewrite this expression, if 1/2 equals 1/5 to the h, I'm saying for what value of h is this going to be true? Okay, for what value of h is this going to be true? Because again, I'm trying to get this in this format. So I'm looking for an h that's going to satisfy this. I'm trying to set this up so that this equation says c over t equals 19 to the 1/2 raised to, or excuse me, 19 times 1/2 raised to t over h, okay? So far I've got my 19 in place, I've got my t over h in place. So this phrase in the parentheses, this 1/5 to the h, I need to figure out for what value of h this is true to kind of squeeze everything into my half-life formula, okay? So I'm kind of manipulating things, trying to get it to fit. So 1/2 equals 1/5 to the h. So for what value of h is this true? This is when I bring out my calculator. So let me pull that up. So I had 1/2 and I had 1/5 to the h equals 1/2. So remember, to solve this, and I know it might be a little bit small, to solve for h in an equation in the form of a to the h equals b, enter a on the left, enter b on the right. So my equation was 1/5 to the h equals b. So I'm going to just type in this box 1 divided by 5, and it'll convert it to a decimal for me. Okay, notice how it automatically was written as 0.2. And then remember, b was equal to 1/2, and you can already see the 0.5, but I'll rewrite it anyway. So I've got 1/2, that's 1/2. If I click outside of the box, I've set up this equation, and this is just a handy little calculator that's going to do this for me. So you can see that it's kind of re-representing it here, 0.2, or which is equal to 1/5, to the h is equal to 1/2, or 0.5, and they approximate h to be about 0.43. Okay, and that's going to be my answer, 0.43. So h is about 0.43. So what we're saying is that I could rewrite this equation like this. C of t equals 19. Then I'd have my brackets here, 1/5 to the h, t over h equals, I would just write it like that, right? Or I could write it as c of t equals 19. I know that this is equal to 1/2, right? So I can just write 1/2. T over, I solved for h equals about 0.43. All right, so I've got this now in the right format, and what we're saying is now look how easy it is to figure out what the half-life is. it must be this 0.43, h is equal to 0.43. So my half-life for my example is 0.43, and you'll use similar means to figure out your half-life here. Now, if that wasn't totally clear, don't worry, because the next two examples are very similar. You know, not the same numbers, but we're going to be doing the same computation given the same information. So the last one was called star sand or something like that, right? This time we are figuring out the half-life for a different potion. This is diamond dirt, all right? So notice once again you get a similar format. Remember that we're aiming to have something that looks like this, or we've got our Q of t is equal to Q sub 0 1/2 to the t over h, where Q of t is my amount, Q sub 0 is my initial amount, 1/2 is representing the fact that we're reducing it to, you know, that's the half-life part of it. This is when my concentration has reached 1/2, t over h. All right, so I'm just going to talk through this one as well, and once again I'll just make up an equation that will be an appropriate model for the one you have. So let's say that I had E of t equals 50. Let's make my fraction 1/4 to the t. All right, so I'm using E of t as my model for D of t. And I have to figure out the half-life of E of t. So we're saying that my amount, E of t, is equal to my initial value. So this is like my initial amount of this potion that I started with, okay? 1/4 to the t. So my goal is to use what I know about exponents and get my E of t equation in the same format as Q of t. So the only thing that'll look different is that I will, you know, Q of 0 I know is equal to 50, so I'll plug in 50, and then I'll actually have h solved for. All right, that's the direction I'm going in. So I know I want to get it so that I have this h exponent dividing my t. So once again, I'm going to take E of t equals 50, and here's what I'm going to do. Let's just kind of act like we're like zooming in on this part, right? So I've got, this is my end parentheses, this parenthesis right here. I've got t, right? Now, once again, I'm going to multiply t, my exponent, times h over h. And I'm allowed to do that because h over h is equal to 1, and anything times 1 is just equal to itself. Now, I could rewrite that as th over h, right? And that's the same thing as, let's just kind of keep rewriting it, that's the same thing as t over h times h, right? So t over h, or t times h over h, this guy, t times h over h, is the same thing as th over h is the same thing as t over h times h. This is all, these aren't even exponent rules at this point. I'm just using, you know, kind of multiplication rules, right? So now what I say is, all right, according to my little blueprint, according to my little map, I do want to have a t over h on the outside of my parenthesis, just like this. But this h is in my way, I don't want it here, so my way of kind of getting rid of it and to force the equation to fit the way I want it, I'm going to put my h on the inside of the parenthesis. So now I've got my h exponent on the inside, and then my t over h exponent on the outside, all right? So that's how I get to this point. Now again, if that explanation didn't make total sense, I would recommend that you at least do practice your exponent rules, but it's also okay if you just remember, you know, hey, this is the step that I take to get h where I need it. So I would rewrite this. I've got 50, 1/4 to the h times t. There we go. All right, so now I've got this format, right? I've got E of t equals 50 times the quantity 1/4 raised to the h. I'm adding that extra set of parentheses just to make it extra clear that I'm raising the whole fraction, 1/4. I'm raising that whole fraction to h. And then that expression is being raised to t over h. All right, so again, remember that my next kind of part is that I know that this now, whatever is in here, must be equal to 1/2. So I say, all right, well, if I know that the inside of those parentheses is equal to 1/2, then I can set 1/4 to the h. I can set that equal to 1/2, and I can figure out what h is based on that information. And here's where I open up my tool to solve for h. Notice that anytime we're doing a half-life problem, I mean at least of this format, I can just leave the right-hand side the same, right? I can leave that right-hand side the same, because in this case, for my half-life stuff, b is going to stay 0.5. I'm only just manipulating this left-hand side. So this time, my fraction, my a, was 1/4, so I type in 1/4, I click calculate h, and it says that h is about 0.5. So I have just found, using my calculator, that h is about 0.5. So now I get to rewrite e of t, and I can say, all right, e of t is equal to 50, which is my q sub 0, times 1/2. 1/2 is equal to this expression, remember, to the t over my h, which is approximately 0.5. Okay? So you could have just stopped and said, all right, well, I figured out that my h, my half-life, is 0.5. You could have answered it right there. The reason that I'm choosing to rewrite this for you one more time, if you were just shown this expression from the get-go and they said, what is the half-life, you would easily be able to identify the half-life right here. The half-life h in this case is equal to 0.5. Okay. Let's do this one more time. So this time we've got liquid light. Liquid light represented by the equation L of t equals 79 times 1/21 to the t. We want to know this half-life, and once again I'm just going to make up an example and run through it just to give you one more attempt to kind of nail this concept. So this time I will use, I don't know, k of t. Let's say it's equal to 88, and then my fraction will be 1/15 to the t. Alright, last time through, I'll do it a little bit faster this time. I won't explain all the steps as I've done before. If you feel that you need to hear the steps again, maybe just rewind and listen to one of my first examples. Alright, so I've got k of t equals 88 times the quantity 1/15 to the t. I want to find out the half-life. So I'm trying to get this in my half-life format, which I will write down one more time. In an effort to get this, my exponents under control, I am going to multiply my exponent t times h over h, and then I'm going to use exponent rules to manipulate this into looking like this. So I now have an h on the inside, I have an h as a denominator. Now I know, since I'm fitting this into a half-life format, I know that 1/15 to the h must equal 1/2. I'm going to take out my half-life calculator. I'm going to type in 1/15. 1/15. I get 0.26. So I can rewrite this as k of t equals 88 times 1/2 to the t over, I've already forgotten, I think it was 0.26, was that right? Yes, alright. So, note now that I have rearranged k of t so that it fits that format. I've got k of t equals 88 times the quantity 1/2 to the t divided by 0.26. My answer, what is the half-life? My answer here would simply be 0.26. Alright, and for any half-life, if you are using the half-life calculator, which is linked in your project, and it's that calculator that I've been pulling up frequently, I would just write the exact number that it gives you. So it's been giving me a number to the nearest hundredth, right, for the most part. I would just type in the exact answer that the calculator gives you, is my recommendation. All right, so that would be the half-life of my example equation. And finally, so we've gone through 3 examples of calculating half-life. Finally, you're asked to do a paragraph answer. So in this project activity, you rearranged formulas in order to highlight quantities. You should also know how to rearrange formulas to isolate variables. That's what we did for the last portion of the project. It was all about isolating variables. Now compare and contrast these 2 tasks. So essentially, think about what you did for the project, whether it was yesterday or earlier today, the portion from lesson 6. Think about what you've done today and write a paragraph that compares and contrasts these. Now, I do expect a paragraph here, especially since today's component, or the lesson 7 component that we've just reviewed, was quite a bit shorter than what you had to do for lesson 6. So really take your time and work this out. For those of you who might still be intimidated by those half-life problems, notice that calculation-wise, we were only using the calculator for a split second. Most of it was sort of analyzing and manipulating the equation to kind of get it how we wanted, right? But the actual calculator part only came in for a split second. So if you're confused, if you're still not totally confident, just keep practicing it. The more you practice, the more it sinks in, and I'm sure you'll be an expert at this in no time. All right, thanks guys. I'll see you next time.